Water-cooled computer. First, I will spend a brief time talking about why a water-cooled PC is a useful way to cool your PC. Then I will get into the different things that are needed in order to cool your computer. I will also briefly touch on the dangers of water cooling a PC. There are many reasons to cool a PC, first of which is the obvious reason, to keep your PC cooler than you would with a traditional air-cooled solution. This in itself has many benefits. The cooler your PC runs, the longer your computer will last. Another benefit to water cooling is that you are able to overclock your computer higher, which your games and productivity will benefit from. The faster your computer runs, the less lag time you will have in games and the more numbers your computer will crunch. Another reason to water cool is the wow factor or bragging rights. You can bring your friends in and get to see their jaws drop as they look at the monster of tubes and UV lighting water rushing through. A properly made water-cooled system can just scream, "I am a gamer, look at me." So, now let's get into the different components of a water-cooled system and briefly their importance. First of all, the CPU and the GPU block. These are the parts of the loop that keep your CPUs and GPUs cool. Now, like every component in a water-cooled loop, not every block is made the same. Most blocks are made of copper, but some are made of metals like nickel-plated copper. Copper has great heat transfer properties and therefore very commonly used. However, copper tarnishes over time, and seeing how a lot of water mods care about looks, a lot of them use nickel-plated copper as it doesn't tarnish. A few other things to consider about water-cooled blocks is flow rate, jet plates, and fins versus hashes. First off, flow rate, the transfer of flow rate, generally speaking, the better the cooling. Some blocks have jet plates, which do restrict the flow, but force the water to hit the water block with a higher pressure, thus transferring heat better. And lastly, hashes versus fins. Hash grooves are the crisscross lines cut into a loop from the inside of the block to provide more surface area for the water to touch in order to transfer more heat. However, this causes lower flow rates as it breaks up the water flow, which is where slotted fins tend to work better, as they are straight grooves cut into a block which allow the water to keep flowing, yet still offer great surface area to transfer heat. The next major part of a cooling loop is the pump. With a pump, it is important to have power. The more power, the faster the flow rate, and the better the heat transfer. When buying a pump, you need to consider a few things. How many components are in the loop? Just the CPU block? Or are you going to have the CPU block, a GPU block, a chipset block, and so on? The more components in a loop, or the longer the loop, the more powerful a pump you will need to push the fluid further. The other way to create more force to push the fluid is to add more than one pump. The more pumps that you have, the better the flow rate to push the water along the loop. The next part in the loop that you need is a radiator. This is where the heat will transfer to the air and where the temperature of the water will cool back down and then go around the loop to start the process again. Not all radiators are the same either. Some are copper and some have aluminum fins and so on. You also need to decide how big your radiator should be. Do you want it to only handle 2 fans at a higher speed, producing more noise? Or do you want a 9-fan radiator that can effectively cool better, but with quieter, slower spinning fans? Rule of thumb, the greater the surface area of the radiator, the better the cooling. Next up is the reservoir. This is the part of the loop that holds the water, whereas this is the key component of the loop. It generally won't make a difference the size or shape of the reservoir. The main deciding factor of picking out a reservoir is where you're going to put it. In other words, how much space is available, and is it aesthetically pleasing? Does it look cool? The last 2 main components is tubing and fluid. It is important to have a soft bendable tube, yet one that will not kink easily. If it kinks, the water flow is cut off, and that is bad. There are a lot of tight bends as there is little space in the computer to work with. Choice of fluid is important, as some transfer heat better than others, and also fluid like Fessor fluid is non-conductive, meaning it won't transfer electricity. There are, of course, other components you can add to the loop. Things like hard drive water-cooled bays, memory water cooling blocks, chipset blocks, and even MOSFET blocks. They are even water-cooled power supplies. Not something I would do, but hey, that's what makes water cooling, excuse the pun, cool. You get to personalize your water cooling loop. No two loops will ever be the same. And now for the wrap-up. The dangers associated with water cooling. Fluid and electricity don't mix. If a water-cooled system is not properly set up and maintained, it could lead to a major disaster. Even one drop of fluid can burn up your entire PC and even cause a fire. This is the one reason for non-conductive fluid. Whereas it can still cause damage, it is not as likely. So now that you have a brief explanation of water cooling, is it something that you want to do? This is a question that you need to answer before you start. Just make sure you do your homework and spend the most time researching the subject before you start. And lastly, I've supplied a slide of what a really well thought out and designed water-cooled computer looks like. This PC is not only laid out very well, but it also has every component water-cooled in the system, but it also is very, very appeasing to the eyes to create that wow factor for when your friends come over.